This story exploring how rivers originated on Earth, blending scientific insights with our research. The Birth of Rivers, a journey through time long ago when the Earth was a young and tumultuous planet. It was a place of chaos, fire and transformation. The story of rivers during a time when the Earth was forming its identity. A tale etched in the fabric of its landscapes, written by the forces of nature. The molten beginning over 4.5 billion years ago, Earth was a fiery ball of molten rock. Volcanoes spewed gases into the atmosphere, creating a thick, toxic envelope around the planet. Water as we know it did not yet exist in its liquid form. Instead, water molecules were locked within minerals deep in the Earth's mantle or drifting as vapor in the dense atmosphere. The planet's surface was constantly reshaped by violent impacts from meteors and comets. Among these celestial visitors were icy comets, carrying precious water from the far reaches of the solar system. Each collision brought more water to Earth, slowly adding to the planet's reservoir. Meanwhile, deep within the Earth, tectonic forces churned the molten rock, releasing water vapor from the mantle into the air. This vapor joined the gases from volcanic eruptions, creating an atmosphere rich in carbon dioxide, nitrogen and steam. As the Earth began to cool, a miraculous transformation took place. The relentless rains began. The deluge. For thousands of years, rain poured from the sky in an unending deluge. The Earth's surface, once dominated by fiery lava flows, was gradually cooled and sculpted by the ceaseless downpour. The water pooled in low-lying areas, forming the first primitive oceans. These vast bodies of water were the birthplace of life, but they were also the precursors to rivers. The early Earth's surface was jagged and uneven, shaped by tectonic activity and meteor impacts. As rainwater collected and began to flow downhill, it carved channels into the landscape. These channels, guided by the pull of gravity, formed the first streams and rivulets. The dance of continents. The Earth's crust was far from stable. Tectonic plates drifted across the planet, colliding and pulling apart, creating mountains, valleys and basins. These geological changes gave rise to the diverse landscapes that would become home to rivers. One of the most dramatic moments in this saga occurred around 3 billion years ago when the first supercontinent, Ur, began to form. As tectonic forces pushed landmasses together, towering mountain ranges were born. Rainwater, fed by the planet's growing hydrological cycle, began to flow down these mountains, carving paths through the rock. The earliest rivers were born, their waters rushing to meet the primordial oceans. These rivers were unlike the rivers we know today. They were short-lived, often redirected or destroyed by volcanic eruptions and earthquakes, yet they marked the beginning of a profound relationship between water and the land, a relationship that would shape the Earth for billions of years. The role of life. As rivers carved their paths across the Earth, life began to emerge in the oceans. Around 3.5 billion years ago, the first simple organisms appeared, thriving in the planet's watery environments. These microbes played a crucial role in transforming the atmosphere, producing oxygen through photosynthesis. Over millions of years, the increase in oxygen levels led to the formation of the ozone layer, which protected the Earth's surface from harmful ultraviolet radiation. This allowed life to colonize the land, bringing new dynamics to the planet's ecosystems. Rivers became lifelines for these early terrestrial organisms, providing water, nutrients, and a means of transportation. Over time, they became habitats in their own right, teeming with life and connecting diverse ecosystems. The great rivers take shape as the eons passed. The Earth's surface continued to evolve. Around 2.5 billion years ago, the supercontinent Nuna formed, followed by Rodinia, Pangaea and others. Each of these supercontinents played a role in shaping the rivers we see today. The breakup of these massive landmasses created rift valleys, which became fertile grounds for river formation. Rivers like the Nile, the Amazon, and the Yangtze trace their origins back to these ancient geological processes. During the last 500 million years, rivers began to resemble their modern counterparts. The planet's climate stabilized, allowing for the development of long meandering rivers that flowed across continents. These rivers carried sediment from the mountains to the seas, creating fertile floodplains that would become cradles of civilization. Rivers and humanity. Rivers have always been intertwined with the story of humanity. The earliest human civilizations, from Mesopotamia to the Indus Valley, arose along riverbanks. Rivers provided water for drinking, agriculture, and transportation. as well as a source of inspiration. For culture and spirituality, the Nile with its predictable floods allowed the ancient Egyptians to develop a sophisticated agricultural system. The Tigris and Euphrates rivers nurtured the civilizations of Mesopotamia. Known as the cradle of civilization, the Ganges became a sacred river in India, while the Yangtze and Yellow rivers supported the growth of Chinese culture. Rivers were also pathways for exploration and trade, connecting distant regions and fostering cultural exchange. They shaped the boundaries of nations and influenced the course of history. The changing rivers today, rivers continue to shape the earth, but they are also shaped by human activity. Dams, irrigation systems, and pollution have altered the natural flow of many rivers, with profound consequences for ecosystems and communities. Climate change poses new challenges, affecting rainfall patterns and causing glaciers to retreat, threatening the water supply of rivers fed by snow and ice. Yet, rivers remain vital to life on Earth, reminding us of their ancient origins and their enduring importance. Conclusion: rivers. As Earth's veins, the story of rivers is the story of Earth itself, a tale of transformation, resilience, and interconnectedness. From their humble beginnings as rainwater carving channels into volcanic rock, to their role as lifelines for civilizations, rivers have shaped the planet in profound ways. As we look to the future, the challenge lies in preserving these precious waterways, ensuring that they continue to sustain life for generations to come. The river's journey, billions of years in the making, is far from over. It is a story that flows onward, shaped by the forces of nature and the choices of humanity. Top 10 biggest rivers by volume today, measured by average water discharge. Amazon River, South America, average discharge approximately 209,000 cubic meters per second, cubic meter per second. Length approximately 6,575 kilometers. Congo River, Africa, average discharge approximately 41,800 cubic meters per second. Length approximately 4,700 kilometers. Ganges, Brahmaputra Meghna River System, Asia, average discharge approximately 38,129 cubic meters per second. Length approximately 2,525 kilometers. Ganges plus 2,900 kilometers. Brahmaputra Orinoco River, South America, average discharge approximately 37,740 cubic meters per second. Length approximately 2,140 kilometers. Yangtze River, China, average discharge approximately 30,166 cubic meters per second. Length approximately 6,300 kilometers. Madeira River, South America, average discharge approximately 31,200 cubic meters per second. Length approximately 3,380 kilometers. Rio Negro, South America, Amazon tributary, average discharge approximately 28,000 cubic meter per second. Length approximately 2,250 kilometers. Yenisei River, Russia, average discharge approximately 19,600 cubic meters per second. Length approximately 5,539 kilometers. Paraná River, South America, average discharge approximately 17,290 cubic meters per second. Length approximately 4,880 kilometers. Mississippi Missouri River System, USA, average discharge approximately 16,792 cubic meters per second. Length approximately 6,275 kilometers. Top 10 oldest rivers on Earth, estimated by geological age. Finke River, Australia, age approximately 350 million years. Meuse River, Europe, age approximately 320 million years. New River, USA, age approximately 300 million years. Susquehanna River, USA, age approximately 250 to 300 million years. Nile River, Africa, age approximately 30 million years. Murray River, Australia, age approximately 25 million years. Indus River, Asia, age approximately 5 to 15 million years. Colorado River, USA, age approximately 6 million years. Amazon River, South America, age approximately 11 million years. Yangtze River, China, age approximately 25 million years. Country with the most rivers. Russia. Estimated number of rivers, over 100,000 rivers. Notable rivers, Volga, Lena, Yenisei, Ob and Amur. Russia's vast size and diverse geography, including tundras, forests and mountains, contribute to its large number of rivers. Country with the fewest rivers, Saudi Arabia. Natural rivers, 0 instead of rivers. Saudi Arabia relies on wadis, which are dry riverbeds that temporarily fill with water during rare rainfalls. How many rivers are there in the world? The total number of rivers in the world is difficult to estimate accurately due to varying definitions of what constitutes a river. However, based on geographic surveys, estimated number, around 165 major rivers and millions of smaller rivers and streams worldwide. Many of these are not named or mapped, especially in remote regions. The most dangerous river, claiming the highest deaths, the Yangtze River, China, is often considered the most dangerous due to its strong currents, frequent flooding, and industrial pollution. Flooding. The Yangtze has caused some of the deadliest floods in history. The 1931 Yangtze River flood resulted in an estimated 1–4 million deaths. Pollution. High industrial activity makes its water hazardous. Navigation hazards, strong currents, whirlpools and debris pose dangers to boats. Other deadly rivers, Zambezi River, Africa, known for crocodile attacks, hippos and strong rapids, e.g. Victoria Falls. Amazon River, South America, home to dangerous creatures like piranhas, anacondas, and parasitic fish. Countries without any rivers. Several countries lack permanent rivers, mainly due to arid climates or small geographical sizes. These include Saudi Arabia, Bahrain, Kuwait, Malta, Oman, Qatar, United Arab Emirates, Vatican City. These nations often rely on wadis, reservoirs, or desalination for water. Which rivers have drinkable water and which don't? Rivers with drinkable water. Rivers with clean, drinkable water are increasingly rare. However, remote or protected rivers may have potable water. Examples include rivers in pristine wilderness areas, e.g. parts of the Amazon or Arctic. Rivers. Glacial rivers, fed by melting glaciers. These rivers can have drinkable water free from industrial pollution. Examples: Bow River, Canada, Ho River, USA. Rivers without drinkable water. Most major rivers, especially near cities, have polluted water unsuitable for drinking without treatment. Examples: Ganges River, India, sacred but heavily polluted. Yangtze River, China, industrial pollution. Citarum River, Indonesia, one of the most polluted rivers in the world. Top 10 deepest rivers in the world. Congo River, Africa, approximately 220 meters, 722 feet. Yangtze River, China, approximately 200 meters, 656 feet. Amazon River, South America, approximately 100 meters, 328 feet. Mississippi River, USA, approximately 61 meters, 200 feet. St. Lawrence River, Canada, USA, approximately 65 meters, 213 feet. Zambezi River, Africa, approximately 116 meters, 381 feet. At Batoka Gorge, Paranal River, South America, approximately 50 meters, 164 feet. Mekong River, Asia, approximately 100 meters, 328 feet. Hudson River, USA, approximately 62 meters, 204 feet. Danube River, Europe, approximately 50 meters, 164 feet. Rivers flowing year-round versus seasonal rivers. Year-round rivers. These rivers are fed by consistent sources like glaciers, groundwater or perennial rain, ensuring steady flow throughout the year. Examples: Nile River, Africa, Amazon River, South America, Yangtze River, China, Mississippi River, USA, Rhine River, Europe. Seasonal rivers. These rivers flow only during specific seasons, usually the rainy season, and dry up at other times. Examples: Luni River, India, Todd River, Australia. Wadis in the Middle East and North Africa, countries that have made their rivers safest to avoid flood. Several countries have implemented extensive flood management systems, river engineering, and disaster preparedness programs to minimize flood risks. The following are examples of countries with effective river safety measures. 1. Netherlands. Key measures: advanced flood protection infrastructure like the Delta Works, a series of dams, sluices, and storm surge barriers. Room for the River program, which widens rivers and restores natural floodplains. Notable rivers: Rhine, Meuse and Scheldt. 2. Japan. Key measures: flood bypass systems. Tokyo has underground flood control systems, such as the metropolitan area outer underground discharge channel, MAU-DC. Extensive river embankments and dams. Notable rivers: Tone River, Shinano River. 3. China. Key measures: the Three Gorges Dam on the Yangtze River, the world's largest hydroelectric project, regulates water flow and mitigates floods. Investment in flood diversion zones and reservoirs. Notable rivers: Yangtze, Yellow River. 4. Germany. Key measures: integrated river management projects like restoring floodplains along the Rhine River, advanced flood forecasting systems and dike reinforcement. Notable rivers: Rhine, Elbe, Danube. 5. United States. Key measures: the Mississippi River and Tributaries Project includes levees, floodways and reservoirs, dams, and spillways to manage river flow in regions like the Missouri and Mississippi River basins. Notable rivers: Mississippi, Missouri, Colorado. 6. South Korea. Key measures: the Four Major Rivers Restoration Project improves flood control by widening river channels and building reservoirs. Notable rivers: Han River, Nakdong River. 7. Bangladesh. Key measures: comprehensive embankment systems and community-based flood early warning programs. Notable rivers: Ganges, Brahmaputra, Meghna. 8. Singapore. Key measures: extensive drainage systems, flood detention reservoirs, and the Marina Barrage, which prevents flooding in low-lying urban areas. Notable rivers: Singapore River, modified for urban flood control. Rivers with the most dams: certain rivers have been heavily dammed for hydroelectric power, irrigation, flood control, and water supply. Below are the rivers with the most dams. 1. Yangtze River, China. Number of dams: over 50 major dams. Key dams: Three Gorges Dam, Gezhuba Dam. Purpose: flood control, hydroelectric power, navigation. 2. Colorado River, USA, Mexico. Number of dams: approximately 15 major dams. Key dams: Hoover Dam, Glen Canyon Dam. Purpose: irrigation, water supply, hydroelectric power. 3. Nile River, Africa. Number of dams: approximately 10 major dams. Key dams: Aswan High Dam, Egypt, Rosiers Dam, Sudan. Purpose: flood control, irrigation, power generation. 4. Volga River, Russia. Number of dams: 8 large dams in the Volga-Kama Cascade. Purpose: hydroelectric power and navigation. 5. Mekong River, Asia. Number of dams: 11 mainstem dams in Laos, Cambodia and China, and over 100 tributary dams. Purpose: hydropower, irrigation. 6. Amazon River, South America. Number of dams: approximately 154 existing dams, with more planned on tributaries. Key dams: Belo Monte Dam, Brazil. Purpose: hydropower. 7. Mississippi River, USA. Number of dams: approximately 29 locks, and dams mainly for navigation. 8. Paraná River, South America. Number of dams: several large dams including the Itaipu Dam, the world's second largest hydroelectric facility. Purpose: hydropower. 9. Ganges River, India, Bangladesh. Number of dams: numerous large dams like the Farakka Barrage. Purpose: irrigation, water supply. 10. Indus River, Pakistan, India. Number of dams: several including the Tarbela Dam, one of the world's largest earth-filled dams. Purpose: irrigation, water storage. Let me know if you'd like further details or insights on any of these. Here are the top 10 countries prone to frequent floods with poor flood management systems leading to devastating impacts. 1. Bangladesh flood frequency: extremely high. Why? Low-lying deltaic region vulnerable to monsoon rains, river overflows, Ganges, Brahmaputra, Meghna, and cyclones. Poor infrastructure and lack of sufficient embankments and drainage systems. Challenges: overpopulation and deforestation exacerbate the problem. Flood forecasting systems are underdeveloped for rural areas. 2. India flood frequency high, e.g. annual monsoon floods. Why? Major rivers like the Ganges, Brahmaputra and Godavari overflow during monsoons. Urban areas like Mumbai suffer from clogged drainage systems and poor urban planning. Challenges: inadequate disaster management in rural regions. Urbanization reduces natural drainage. 3. Pakistan flood frequency frequent, e.g. Indus River floods. Why? Glacial melting, monsoon rains and river overflows. Indus and its tributaries. Deforestation in northern areas worsens flash flooding. Challenges: insufficient dams and reservoirs. Limited government resources for flood relief and planning. 4. China flood frequency high in some regions. Why? Rivers like the Yangtze, Yellow and Pearl are prone to flooding due to heavy rains and rapid snowmelt, over-reliance on large dams like the Three Gorges Dam instead of distributed flood management solutions. Challenges: urban sprawl worsens drainage problems, industrial pollution increases flood risks. 5. Indonesia flood frequency frequent, e.g. Jakarta experiences annual floods. Why? Intense monsoons and deforestation in upstream areas. Rivers overflow due to poor waste management clogging waterways. Challenges: lack of urban drainage and flood forecasting systems. Land subsidence in cities like Jakarta worsens flooding. 6. Philippines flood frequency frequent due to typhoons and heavy rains. Why? Prone to tropical storms and typhoons that bring torrential rains. Rivers in urban areas lack sufficient drainage and embankments. Challenges: inadequate infrastructure in rural regions. High poverty levels prevent effective disaster mitigation. 7. Vietnam flood frequency high in low-lying areas. Why? The Mekong Delta is prone to seasonal flooding. Typhoons bring heavy rainfall, overwhelming existing embankments. Challenges: lack of proper floodplain management, poor urban planning in coastal and riverine areas. 8. Nepal flood frequency frequent due to heavy monsoons and glacial melting. Why? Mountainous terrain contributes to flash floods and landslides. Rivers like Koshi overflow and breach poorly constructed embankments. Challenges: limited resources for flood control, poor coordination with downstream countries like India. 9. Nigeria flood frequency increasingly frequent. Why? Intense rainfall during the wet season causes rivers like the Niger and Benue to overflow. Poor urban planning leads to blocked drainage systems. Challenges: weak disaster response mechanisms, poor maintenance of existing dams and levees. 10. Myanmar flood frequency frequent in monsoon season. Why? Irrawaddy River and its tributaries flood low-lying areas. Deforestation and poor water management amplify flood risks. Challenges: limited disaster preparedness in rural areas. Political instability hinders flood management efforts. Key issues with poor flood management in these countries: urbanization. Poor urban planning clogs drainage systems, reducing natural water flow. Deforestation. Removal of trees increases runoff and worsens flash floods. Lack of infrastructure, few embankments, dams, and flood control systems. Insufficient forecasting. Early warning systems are often unavailable in rural areas. Political instability, limited government capacity to invest in disaster prevention. Several rivers have experienced periods of drying up completely or partially, only to resume their flow after years or decades due to natural or human interventions. Here's a list of notable rivers that have gone dry for extended periods and eventually flowed again. 1. Saraswati River, India. Historical significance. Believed to be an ancient river mentioned in Hindu scriptures, it is thought to have dried up due to tectonic shifts and changes in river courses around 2000 BCE. Resumption. Efforts to revive the Saraswati have been made in modern times by tapping groundwater and reconstructing its ancient channels. 2. Colorado River Delta, USA, Mexico. Dry period. Large portions of the Colorado River Delta in Mexico went dry due to excessive water diversion for agriculture and urban use in the U.S. Resumption. In 2014, a planned release of water, pulse flow, allowed the river to reach the Gulf of California for the first time in decades. 3. Sayende Rud, Iran. Dry period. This river dried up for extended periods due to over-extraction for agriculture and urban use, as well as poor water management. Resumption. Temporary releases of dam water and rainfall occasionally restore its flow, though it remains inconsistent. 4. Rio Grande, USA, Mexico. Dry period. Sections of the Rio Grande have gone dry, particularly in Texas, due to heavy water extraction and droughts. Resumption. Heavy rains or reduced water demand occasionally restore parts of its flow. 5. Yellow River, China. Dry period. The Yellow River dried up in its lower reaches multiple times during the 1990s due to overuse and drought. Resumption. Improved water management policies and dam releases have helped restore its flow in many areas. 6. Murray River, Australia. Dry period. The Murray River has experienced severe droughts, particularly during Australia's Millennium Drought 1997 to 2009. Resumption. Improved rainfall and water management helped the river flow again after the drought ended. 7. Limpopo River, Southern Africa. Dry period. This river often runs dry during prolonged droughts, particularly in Mozambique and South Africa. Resumption. heavy rainfall brought by seasonal weather patterns restores its flow. 8. Amudaya Central Asia dry period. Excessive water withdrawal for agriculture has significantly reduced its flow, and some sections have dried up completely. Resumption. Seasonal glacial melting and occasional rains bring water back to its channel. 9. Nile River, Africa, historical dry periods. Archaeological evidence suggests that parts of the Nile experienced significantly reduced flow during ancient droughts, particularly during the 4.2 kiloyear event 2200 BCE. Resumption. Natural climatic shifts brought rainfall back to its watershed. 10. Pilcomayo River, Bolivia, Paraguay. Dry period. Sections of the river have dried up due to sedimentation and prolonged droughts. Resumption. Dredging and seasonal rains have helped restore its flow. Key reasons for rivers becoming dry and resuming. Climate variability. Extended droughts or shifts in rainfall patterns can dry rivers, while wet seasons or monsoons restore flow. Overuse, excessive water withdrawal for irrigation, industry or urban use can deplete rivers, but conservation efforts or reduced demand can help them recover. Tectonic activity, geological changes can alter river courses or disrupt flow, with some restoration possible through natural shifts or human engineering. Sedimentation, accumulated sediment can block river channels, but dredging or natural floods can clear these obstructions. There are rivers that have come into existence in the last 5 centuries due to natural geological processes, climatic changes, or human interventions, while most major rivers are ancient and formed millions of years ago. Some younger rivers or streams have emerged more recently. Below are notable examples. 1. Lava-created rivers, Iceland and volcanic regions formation process. Volcanic eruptions can create new river courses when molten lava blocks or redirects existing streams, or when glaciers melt rapidly due to volcanic heat. Examples: Iceland has seen new rivers form in its dynamic volcanic landscape, especially after eruptions like the Laki eruption, 1783. 2. Glacier melt rivers, global, especially polar and mountain regions, formation process. Rivers have emerged due to the retreat of glaciers during the Little Ice Age and modern global warming. Examples: meltwater rivers in Greenland and Antarctica. As glaciers melt, they form new rivers and streams, such as those on the Greenland ice sheet. New Himalayan rivers. Glacial retreat in the Himalayas has led to the creation of smaller rivers and tributaries over the last few centuries. 3. Aral Sea tributaries, Central Asia formation process. The desiccation of the Aral Sea due to human water diversion led to the development of new, smaller rivers and drainage channels as water patterns shifted. Timeline: many of these changes have occurred since the 20th century. 4. Rift Valley rivers, Africa formation process. The East African Rift Valley is tectonically active, and new rivers and lakes form as land depressions fill with water. Examples: Lake Turkana tributaries. New tributaries have formed due to tectonic shifts in this region in the past few centuries. 5. Brahmaputra rivers changing channels, India, Bangladesh, Tibet formation process. The Brahmaputra's path has shifted significantly due to tectonic activity and sediment deposition, leading to the creation of new channels and distributaries. Timeline: major changes in the Brahmaputra's course occurred in the last few centuries, creating new river paths. 6. Colorado River Delta channels, USA-Mexico formation process. Human-engineered water releases and shifts in agricultural water use have created new river pathways. Timeline: notable changes have occurred since the 19th century, with additional tributaries forming during restoration efforts. 7. Lake Missoula flood outlets, USA formation process. Although these rivers largely formed earlier, some new channels were carved out during ice dam breaches in the Pacific Northwest, particularly during the Pleistocene epoch. Continued changes: some smaller streams in the region have formed within the last 500 years due to ongoing sediment erosion. 8. Human-made rivers and channels formation process. Rivers or river-like channels created by humans for agriculture, transportation or flood control. Examples: Dubai Water Canal, UAE, a recently constructed artificial river that extends through Dubai. New Danube, Austria, a man-made channel created for flood control purposes. Indira Gandhi Canal, India, transformed a desert region in Rajasthan into a fertile area, essentially acting as a new river. 9. Rivers in Iceland. From Jökullaups formation process. Jökullaups, glacial outburst floods caused by sudden melting of glaciers due to volcanic activity create new water channels and rivers. Timeline. Such events have occurred throughout Iceland's history, with new rivers emerging even in recent centuries. 10. Sinkhole rivers, Yucatan Peninsula. Mexico, formation process. In karst regions, new rivers can form when sinkholes collapse and water finds new underground or surface paths. Timeline. These can form rapidly, often triggered by rainfall or tectonic shifts, and some have emerged in the last few centuries. Key factors for recent river formation: climate change, melting glaciers and rising sea levels lead to new water pathways. Volcanic activity, lava flows and eruptions can create or redirect rivers. Tectonic activity shifts in Earth's crust open up new channels or depressions for rivers to form. Human intervention, artificial channels and restored ecosystems create new waterways. Extreme weather events, catastrophic floods or glacial outbursts create temporary or permanent rivers. Would you like more details on specific examples or the processes behind these formations? Rivers change their course due to natural and human factors. Erosion and sediment deposition constantly reshape riverbanks, altering their path. Floods can carve new channels, while tectonic activity shifts the land beneath, forcing rivers to find new routes. Climate change and glacial melting modify water flow, contributing to course changes. Vegetation and soil loss in watersheds accelerate erosion, influencing river dynamics. Human activities like dam construction, urbanization, and deforestation disrupt natural flow patterns, leading to deviations. Over time, these combined forces create meanders, cutoffs, or entire dynamic balance between water movement, landforms, and environmental changes.